as a work of art, an engineering marvel, and a machine built to best an icon. 2.4 million euro, 1500 horsepower machine called the Chiron. It's the fastest, most extreme, and most exclusive production hypercar. The French-made vehicle shoots along the road at over 420 kilometers per hour. This hypercar scratches at the boundaries of physics, an incredible motorized machine. After nearly a decade of design and engineering, it's finally time to push the boundaries of the automobile. Before the brand can deliver the machine to market, they must first race the clock and crack the 400 km per hour barrier. Every day counts, and there is no margin for error. To awaken the beast in this ultra-powerful work of art, the developers have made the best even better. Molsheim, France, a land rich with history and the home of Bugatti automobiles. This is one of the most unusual car factories in the world. Everything here is artisanal. The Mission, a hyper sports car with 1,500 horsepower and a top speed of 420 kilometers per hour. But the enormous power in this car poses new challenges. Just 500 cars will ever be built, and each one carries a 2.4 million euro price tag. That's before options. Yet two figures really stand out: the 1,500 horsepower engine and the goal to beat its predecessors' outright top speed on the racetrack. It's a huge target, but before they can achieve the goal, they first have to finish developing the machine. To ensure a lightweight car, engineers have fitted the all-wheel drive vehicle with lots of carbon, titanium, and magnesium. Ensuring that the Chiron works correctly is crucial. There's very little about the machine that is normal, and perhaps no car in modern history has had to bend physics quite so far in order to dethrone what came before it. And this hypercar with a 16-cylinder engine is anything but normal. In 2005, the brand introduces the Veyron. It's an incredible machine that has never been seen in the automotive world. 10 years later, however, it's a different story. Competitors nip at the company's heels, and the marque needs a new machine to hold on to their record for the world's fastest production car. Bugatti headquarters, where the vehicle construction happens, is located in Molsheim, France, a Bugatti hypercar factory. These record-holding dream cars have been built on the site of the family estate for the past 115 years. Built in 2004, in the form of the Bugatti logo, they refer to the new construction as the Dream Factory. Inside, 20 employees assemble up to 16 vehicles at once at 12 different stations. With these production figures, Bugatti is among the best automotive manufacturers in the industry. When the project begins, the target is clear, but the path is not. The team's first major decision cuts right to the heart of the matter. To hit a new top speed, they need a brand new engine. Engineers decide that the best course of action is to build upon the Veyron's famed W16 Powerplant. Up in the ante has been a hallmark of the automotive industry since the beginning. It takes 2 months until the French have assembled around 2,600 individual parts to form a new work of art. The Chiron's hood conceals pure performance. The world's most powerful production engine has 16 cylinders and a displacement of 8 litres. This enables the Bugatti to reach its record-breaking speeds of 420 kilometers per hour. 4 offset operating turbochargers, 1,500 horsepower projectile from 0 to 100 kilometers per hour in 2.4 seconds. Instead of a classic production line, There are 4 special stations in Molsheim. They each contain 2 independent lifting platforms because the sports coupe is made up of 2 parts, which the employees connect one another during production. 3 mechanics always assemble what is called the Chiron's rolling chassis, strictly by hand. By 2010, the car world is a very different place. At the dawn of the decade, over 50 different production cars now offer more than 400 horsepower. Almost 60 models come standard with 500 plus horsepower engines, and around 20 more machines have motors producing over 600 horsepower. It is the golden era of the combustion engine. Where the Veyron once stood, all alone, now there are at least 5 different hypercars of producing over 800 horsepower and hitting top speeds in excess of 340 kilometers per hour. Chiron is perhaps the last best hypercar of its era, and the zenith of the internal combustion age. The Monocoque is a hollow driver cockpit and is made entirely of carbon fiber, reinforced plastic, or CFRP. The production crew lifts the 150 kilogram carbon framework onto the platform. Each material that the Bugatti design engineers install fulfills a specific purpose. The technicians install a wiring harness inside the carbon cockpit. The harness consists of a cable and is the nerve system of the Chiron. It connects the vehicle's 20 control units. The mechanics fasten the electrical wires to the monocoque with titanium screws. Like all of the other elements in this racing machine, the wiring harness is also designed as compact and light as possible. The rear frame of the coupe is assembled on the second platform, but first, the workers moved the assembly frame to the heart of the Bugatti, the 640 kilograms 16-cylinder engine. Due to the size and the enormous weight of this unit, the assembly platform comes to the engine in Molsheim. The mechanics use a crane to put the German-built high-performance power plant down on the assembly platform. To exceed the Veyron's top speed, engineers calculate that a new engine needs an increase in power. That's equal to the entire motor in a normal car. 1500 horsepower would be the most powerful engine ever built for a series production car. The engines are manufactured at the Volkswagen engine plant in Salzgitter, covering 2.8 million square meters. This site boasts its own Bugatti department. Whoever works here belongs to the absolute elite among engine mechanics, as the 16-cylinder is considered to be the holy grail of engines. 2 technicians need 1 week to build one of the 1,500 horsepower quad-turbo engines. The power plant takes a long time to engineer, but only 6 days to actually put together. 95% of the power plant is new. When the engine is first fired up, only 2 of the 4 turbos kick in. But once the engine hits 100 revolutions per minute, the other pair spin into action. The result is an engine that produces maximum torque over 70% of the power range. The extra power creates another challenge, namely how to cool the new motor. So the team develops a new water pump that's capable of circulating 800 liters of coolant. That's close to 10 average bathtubs. And at full speed, the pump moves that much liquid through the entire engine every single minute. Once the prototype engine is complete, they take it to an advanced test bench where they discover yet another roadblock. To check the creation, the team has to build a new facility. To prove the engine's metal, they run it for 25 hours straight at full throttle. The 4 workplaces in the engine department are also special. Each station is structured so that a complete unit can be built here. The experts manufacture a total of 3 of these powerful engines per week. To make the engine as compact as possible, 8 cylinders are distributed over each of the V-shaped banks, thus creating an artificial W engine with 16 cylinders. The W16 achieves its maximum acceleration with 4 high-performance turbochargers. Via a turbine, the quartet compresses the air intaken at the front of the vehicle and presses it into combustion chamber in stages, thanks to what Bugatti calls sequential turbocharging. Turbos 3 and 4 cut in at 2,800 RPM. This prevents turbo lag and therefore ensures constant power. At production nest 2, a new crankcase is ready to be assembled. A mechanic has just installed the pistons in the 16 cylinders and connected them to the crankshaft. Before the engine builders continue their work, they use an electronic torque wrench to simulate engine operation. For instance, this allows the workers to check the piston's stroke does not lead to friction on the cylinder wall. Otherwise, serious engine damage, called piston seizure, could occur later while driving. Once the team defines the car on paper, it's time to move it into the digital world. Eventually, you still need to touch and feel the machine. So an artisan sculptor creates a full-size clay model. Each panel is lovingly worked until it's perfect. The artistic lines need to look good, but it's the path that the air travels around the machine that's critical. Funneling clean air sounds easy, but it's not. As the vehicle is pushed forward, it creates turbulence. The more unsettled the air becomes, the less energy it contains, and the W16 Powerplant needs a massive amount of high-energy air. So, the team turns to Dallara, one of the most famous names in motorsports. If you've ever watched the Indy 500, you've seen their aerodynamically tuned chassis in action. The engineering firm starts in 1972, and their early racing success crystallizes the notion that they can harness the wind. The wind tunnel has a fan that produces over 1,000 horsepower. This pushes the air towards the model. Dallara's tunnel can generate wind speeds up to 200 kilometers per hour. It's a far cry from the Chiron's eventual top speed, but fast enough to determine where the cleanest air lives. The relatively tiny scale model helps aerodynamicists measure airflow around the car and even inside it. The Chiron's engine is made up of around 3,700 individual parts. The technicians pre-assemble each individual component at workplaces next to the assembly stand. This worker is assembling various engine elements. Here he is fitting a fuel pump. Later on, it will deliver the required quantity of fuel to the engine. The worker then installs the alternator. Its task is to generate electricity for the starter battery and other electrical components. At the same time, his colleague prepares the oil pan for assembly. It has to be absolutely leak tight because later on, the pan contains the engine oil needed to lubricate the 16-cylinder engine. This is why the technician now takes it to an automatic station. 2 different processes take place here. First, a special oxygen plasma cleans the surface of the pan. Although the engineers pay strict attention to cleanliness, there is still a fine layer of dirt on the components. The station then applies a black sealant onto the edge of the magnesium pan. Once the sealant has been completely distributed, the technician has 20 minutes to assemble the component. To do this, he positions the oil pan over the crankshaft onto the lower side of the engine block and seals it. Only specially trained technicians are permitted to build the Chiron engine. Whoever has successfully completed the additional 2-year training can justifiably feel proud. You can already get a sense of the enormous dimensions of the combustion engine at Station 3. The quad-turbo engine draws its power from the ignition of a fuel-air mixture. These camshafts ensure the correct mixing ratio. Driven by the engine's chain, the cams rotate around their metal shaft and thereby press alternately on the valves of the individual cylinder heads. This enables them to open and close in a specific stroke. The mechanics bolt 2 of these 1 kilogram engine components per cylinder bank. The W16 engine in the Chiron has a total of 4 camshafts. So that the mixture can ignite, the engineers now insert 16 spark plugs into the cylinders. They supply the final pulse for starting the engine. They also influence the 4-stroke engine performance, consumption, and pollutant emissions. The plugs generate a powerful spark, between 500 and 3,000 times a minute. The resulting explosions set the ranks of pistons in the cylinder bank in motion. The stripped engine, meaning all the components needed to operate the drive unit, is now complete. However, the massive power plant is considerably bigger when fully assembled. All further attaching parts are true to the Bugatti philosophy of more power and maximum performance. The final dimensions of the engine in a Chiron are 4 times those of a standard passenger car engine. The team discovers that the air that wraps around the top half of the car arrives at the intakes with 95% of its pressure intact, gets sucked and dives into the air intake, leaving directly down into the engine. The technical insight leads to a distinctive design solution. Once the team solves how to get the cleanest air into the car, they face the next critical task: how to take it away once the engine is done with it. The quest to pull air out of the engine compartment leads to the striking cut-off rear end. Channeling air around the 1500 horsepower engine is just the start. When you're trying to build the fastest production car in the world, you've also got to cool something more than twice as powerful. Since 2005, the engines for the Bugatti brand have been hand-built at the plant in Salzgitter. Even when the company was founded in 1909, the engine blocks were cast by hand by Bugatti. Back then, the engines for the first models were produced at the plant premises in Molsheim. Although working conditions 115 years ago were certainly tougher, the basic structure of high-performance engines has barely changed. With his racing and luxury cars, the Milan-born company founder was considered to be a legend of European automobile history, even back then. Cars like the T35 or the Bugatti Atlantic. Ettore Bugatti was a perfectionist and did incredible things in this plant back in the 20s and 30s. The simple fact that they called the plant atelier rather than a factory is quite a statement in itself. The entire Molsheim site here in Molsheim, France, is unique for an automotive manufacturer because it exudes pure history, and no other manufacturer can offer that. The name Bugatti stood for revolutionary ideas from the get-go. In 1933, Bugatti even built a rail bus with a top speed of 200 kilometers per hour. Ettore was often laughed at for his unconventional ideas, but in the 1920s, Bugatti's super sports cars achieved worldwide fame, thanks above all to their record number of over 2,000 race victories. The name Chiron also played a role back then. Chiron was a racing driver in the 1920s, a very successful one, who won a lot of races in Bugattis. And today, the Bugatti Chiron, named after him, is the ultimate hypersports car. And the engine is at the heart of it. An 8-litre engine with 16 cylinders. The Chiron's 16-cylinder power plant generates 1,500 horsepower, pushes the machine to a planned top speed well over 400 kilometers per hour. Yet going fast is just half the battle. To cool the car's brakes, the team literally attacks the problem head on. Like the Veyron, the Chiron combines mechanical brakes on each wheel with an air brake at the back. The objective of building the world's fastest production car in the form of the new Chiron was viewed very critically by the industry. The whole world said you'll never manage to cram so much power in a car. But the engineers solved precisely this problem. On an internally developed test stand, they put the 8-litre engine through its paces until the manifold blows. Once completed, the engineers test the power output and, above all, the durability of each power plant. Behind the roughly 30-centimetre thick safety wall of the test booth, the team has strapped the combustion engine down and coupled it to a dynamometer. It's able to demand the engine's full output of horsepower at 700 RPM. The stress applied on the test bench is significantly higher than during vehicle operation. A gigantic blower cools the engine during the test. Special sensors measure a total of 500 different values, which the testers check on the monitor. The tests were also important at developing the 16-cylinder engine because the results were incorporated into its 3D model and helped the design engineers to detect possible critical areas. It took 3 years to develop the Chiron's power plant. 2G, or twice the force of gravity, is impressive, yet the power of the mechanical brake is even more surprising. The new brake is 3 times more powerful than the engine. All that power is tested inside of a brake dyno. When you're blazing a new high-performance trail, a big engine and powerful brakes aren't enough. You've also got to develop a new set of rubber. Michelin starts designing a new tyre at their state-of-the-art facility in Clermont, France. Over 30 kilometers per hour, a tyre will experience over 3,000 times the force of gravity just inside its air valve. Le Mans racing cars top out at around 40 kilometers per hour. The new Chiron will be over 25% faster. Calibrating the digital realm with the real one comes down to one of the most powerful tyre dynos in the world. As the start of production looms, the brand's future success on the track might very well hinge on a combination of science and nature. After nearly a decade of deliberation, Bugatti has finally chosen a path for their new supercar. They've built and tested a 1,500 horsepower motor, designed an exterior shape with optimal airflow, and engineered new brakes and tyres, yet the race to the finish line has just begun. During a special auditory test, an acoustic engineer checks whether the exhaust system simulation matches reality. To do this, the sound expert applies a pure tone to the exhaust tailpipes using a loudspeaker. The sound causes the air particles inside the system to vibrate. The engineer records the resonance using a microphone. This allows the sound and the volume to be viewed on the monitor. By 2026, passenger car driving noises have to be reduced to 68 decibels. That's roughly the same as a television at low volume. At the same time, however, the engine sound must not suffer. The acoustic factors are particularly crucial to the experience of driving the Chiron. Noise is relevant. How the windows are constructed, how well the chassis is insulated from the cockpit. All of this characterizes the overall noise perceived by the driver. This all has to be composed to form a consistent concert to achieve a positive experience in the vehicle's interior. And who better to test this experience in new models than a genuine motor racing expert? The former Le Mans winner, Andy Wallace, is Bugatti's test driver. He's already driven around 100,000 kilometers in the luxury sports car, an absolute dream job. The Brit also provides developers with direct feedback about the Chiron's performance and handling from the driver's cockpit. Now the clock is counting down to delivery of the first machine, and the pressure keeps getting harder. To succeed, the team must merge the artistic exterior shell with the technical requirements needed underneath. Back inside Dallara Automobili, they use a very earthly material to design a cutting-edge carbon fiber monocoque. The monocoque is an automotive design technique where the exterior shell of the vehicle provides structural support. The process begins by merging the design department's 3D computer model with the lessons learned inside the wind tunnel. In the atelier in Molsheim, France, the worker transports a newly arrived component. It's the engine block. Two mechanics now couple this 7-speed direct shift transmission to the power plant. The automatic shift unit ensures constant power output when shifting gears, because one clutch closes at the same time as the other is opening. The automatic transmission ensures consistent traction force. The workers then take the new drive unit to an assembly station covering 1,000 square meters. The shop is completely spotless. There's no oil stains anywhere. Looks more like a hospital than a factory. Over the next few hours, the rear section of the vehicle will be built around the high-performance unit. To do this, the Bugatti workers first attach the chassis to the side section of the body alongside the lifting platform. They are also made entirely of carbon. A technician first bolts the independent wheel suspension elements to the carbon fiber framework. The Hypercar has no rigid axle. This means that each wheel can be actuated individually and therefore has maximum grip or contact surface on the asphalt. As a result, the 2-ton Bugatti remains stable even when taking tight corners on a wet road surface. Depending on the driving situation, the onboard computer regulates the 4 wheels, toe and camber to ensure this. The entire substructure of the extreme sports car is adaptive. These suspension struts that the technician is installing can be optionally set to a family car or racing car profile. The hardness of the damper, called its characteristic in technician jargon, is adjusted by allowing more or less oil to flow from one shock absorber tube to the other. The worker now mounts the finished side section on the engine block with his colleague. Building a hypercar is complicated and involves 2,590 individual steps. Great timing in the production sequence is absolutely necessary. For the finite element analysis, there's a computer tool that simulates real-world forces. They first start their evaluation on an individual screen, but soon moves to a much more advanced virtual driving simulator where a pilot can test the car before it's ever been built. Altogether, the team does over 100,000 simulations. Then, the hypercar is fitted with its exhaust system. When the engine is running, temperatures as high as 500 degrees can be reached at the rear muffler. That's why this employee first installs a galvanized heat shield on the exhaust pipes. His colleague carries the gigantic exhaust to the chassis. Later on, 6 tailpipes rid the Chiron of everything that the 8-litre power plant spits out of its 16 cylinders. The team now fastens the enormous titanium muffler to the rear end of the Bugatti. Titanium is light, ductile, and particularly heat resistant. This is important so that the material does not crack under the extreme heat. The crew then clads the mid-engine with further elements to protect it on all sides. It's now becoming cramped in the monocoque. Such a cockpit framework contains a total of 320 square meters of carbon. Placed end to end, all the individual carbon fibers are 9 times the distance from the Earth to the Moon. The mechanic is now fitting the differentials to the underbody of the chassis element. The computer tells him whether he's tightened all of the bolts to the correct torque and stores his production data in the system. This vehicle, with 50,000 degrees of Newton stiffness, is so strong that if you placed 2 average minivans on top of the left front wheel, the right rear wheel would only go up by 1 degree. The fundamental idea behind the machine's stiffness isn't new tech, but rather nature. The architecture that a team uses is similar to honeycomb. The differential compensates the differences in wheel speeds when cornering. The wheels on the inner side of a corner cover a shorter distance than the outer wheels and therefore turn more slowly. Conversely, this means that the outer wheels require more power to cover the greater distance in the same time. A transmission inside the differential distributes the engine's power to the hypercar's individual wheels to varying degrees. Inside an Aerospace-Grade clean room, 50 artisans handcraft the honeycomb structure, where it takes 150 layers and over 1,500 hours to assemble a single monocoque. The process begins by layering carbon fiber sheets in a mold before curing the unit inside an autoclave that bakes the monocoque at 135 degrees Celsius for over 15 hours, like a big cake. Once the unit has cured, it's moved into a climate-controlled, state-of-the-art milling machine, where it'll take an additional day to remove excess material. Then they take yet another day and a half to scan the entire monocoque with an advanced laser to ensure that the chassis is dimensionally accurate. The finished monocoque weighs just 100 kilograms, bringing the vehicle to a stop from its top speed of 420 kilometers per hour poses a major challenge for the brake system. The temperature can soar to 1,100 degrees when the hypercar slams on its brakes. That's as hot as lava. They also install a heat shield before installing the carbon ceramic disc brakes. One of the sport brake discs weighs around 8.5 kilograms. Its caliper is the world's largest 3D printed titanium part. At the time, the Chiron has the most powerful brakes of any production vehicle worldwide. It's not enough for Bugatti. Now it's time to step it up a notch and run the entire vehicle on a chassis dyno. A 3.5-week run simulates nearly a year on the road. The Bugatti crew assembles the front of the monocoque. This worker is fitting a guard for the Chiron's sensitive electronics and mounting a control unit for controlling the vehicle's dynamics. Later on, this ESC helps the driver to keep this hypercar under control. By braking specific individual wheels, for instance, the system prevents the vehicle from sliding out when cornering at high speeds. Over a period of 4 days, the team has installed over 2,600 components at their special stations. An important ceremony is now conducted to the front and rear frames. Like everything at Bugatti, the joining of the monocoque and the rear section is something special. The crew first moves the platforms to the same height. The frame sections have to fit precisely into one another. In the worst case, the construction would have to be taken apart again to adjust individual elements. The three men now maneuver the 750 kilogram rear section to the monocoque. The team steadies themselves as they push to join the two halves. The fact that the Chiron's chassis consists of two parts offers several advantages, so that the driver's cockpit is subsequently stable and therefore as safe as possible. The front section is made completely of carbon. However, the entire body is too big to be built out of this lightweight material. The vehicle is designed so that the rear end can tear off in the event of an accident, because if the engine catches fire, things quickly become dangerous. A total of 14 titanium bolts that the technicians are fastening ensure that the front and rear sections are joined firmly together. Next, the team then takes it to the famed Nardo circuit in Italy. Built in 1975, the course offers a unique 12.5 kilometer banked circle that's so large that you can see it from space. Preventing disasters doesn't just happen on a track. While some prototypes are built to be run hard, others are manufactured to ensure perfection. On the underbody, two Bugatti mechanics now fasten the lines for the operating fluids. Later on, engine and transmission oil as well as brake fluid will flow through these lines. The Chiron's fuel hoses of tough polyamide plastic The airstream at the front end of the vehicle ends up in these two carbon chambers. Via special filters, it flows into the 4 turbochargers compressors, where it is then forced into the cylinders at increased pressure. This means that there is more air and therefore more oxygen for combusting the fuel. The result is a more powerful explosion, higher pressure, and thus linear engine power output. There's just a few weeks left, and the Bugatti Atelier is in full swing, building the final prototypes. The Bugatti's special tyres are custom products from Michelin. With a width of around 36 centimeters, the tyres have to withstand enormous forces during vehicle operation. At maximum speed, the wheels rotate around 50 times per second. This means that 7 metric tons are pulling on their tread. That torches the tough rubber. The Chiron is fitted with semi-slicks that have a lower tread depth and therefore less weight. As a result, the tyres offer plenty of grip despite the enormous centrifugal forces. A set of the semi-slicks costs €9,250. The level of detail is nearly unmatched. The Chiron is now filled with its operating fluids. An employee feeds the vehicle with engine oil, brake fluid, and 40 litres of water. When the car is driving, this is circulated 20 times per minute by the pump to prevent the engine and powertrain from overheating. The mechanic then fills the hypercar's tank. The fuel tank can hold 100 litres of gasoline. The Chiron consumes on average 22.5 litres every 100 kilometres. When you're building a €2.4 million machine, authenticity is the key. The Bugatti's rolling chassis proceeds to its first test station. Bugatti had to develop a new dyno for the Chiron, which is capable of withstanding the hypercar's 1,500 horsepower. This means that the Bugatti dyno is also the most powerful of its kind in the world. A technician first attaches the 2-ton vehicle to these wheel clamps. The safety flap then drops down and the ventilation shafts rise up. Then he fastens fresh air hose to the front of the chassis so that he doesn't suffocate in the cockpit. His colleagues have provisionally added a windshield. He then puts on 2 doors to create the most realistic conditions inside the cockpit. Now the hypercar can show what it's made of for the first time. The employee accelerates up to 200 kilometers per hour. The hypercar has to complete a total of 342 tests. He tests the engine, the transmission, and all the vehicle's dynamic programs for 3 hours. The Bugatti covers around 60 kilometers on the dynamometer. This Chiron has passed all of the tests. The employee releases the vehicle from the wheel clamps and removes the doors. His colleague now takes the car to the next station. At this station, the Bugatti's ready for its body panels. Individual elements are large and fragile. That makes this step extremely demanding. It takes up to 4 days to put the body panels on. Installing the windshield is particularly complicated. It has to be positioned exactly and be completely watertight. To install the windshield, the technicians first apply a primer. They apply a special adhesive to the safety glass. The workers then place the windshield onto the vehicle frame using a vacuum lifter. The 2-part mixture creates an elastic type resin and ensures that the glass can withstand even strong vibrations. Each Chiron is a unique work of art and can be completely individualized. The choice of material and color combinations for styling the vehicle is virtually unlimited. Ettore Bugatti himself once said, "Perfection is never achieved," but to this very day, designers have been attempting to create the most perfect models with a mixture of unbridled power and technical beauty, flawless elegance. To accomplish this, they work closely with the developers because the paramount objective of motorsport artists is form follows performance. The striking C of the Bugatti DNA on both of the Chiron's flanks, therefore also serves a specific purpose. Bugatti's vehicle DNA has constantly evolved according to this principle. Due to its shape, the exclusive coupe's radiator grille has been nicknamed the Horseshoe. In 1910, however, the first Bugatti model, the Type 13, and to improve the vehicle's aerodynamics and cool the increasingly larger engine, the designers adapted the look of the grille to the technical requirements. Probably the only part of a Bugatti whose shape or weight has not been optimized is the brand logo. This Chiron is now almost ready. Each body panel plays a complex role in the aerodynamics. This consists of active and passive systems. All of the components integrated into the paneling are passive. The active modules can be actuated and adjusted to the position and speed of the vehicle. Engineering is often a marathon-like battle of measured steps. Before the team can go flat out for the world record, they need to incrementally prove the machine has what it takes. Today, the goal is to cross the 400 mark for the very first time. With the clock counting down towards production, the team can't afford any setbacks. Small changes can have a big effect on the track. After a few laps, the driver returns to the pits. He can't cross 400 km per hour because the rear wing isn't deploying correctly. And if the team can't get the job done, production can't begin. Before he leaves the pits, the team reworks the deployment control software. A few laps later, he gives it another go. It's taken Bugatti over 200 sets of tyres, 5,500 laps at ERA, and over 100,000 kilometers of testing to get to this point. Now all they have to do is successfully drive past 400 kilometers per hour so that the engineering team can give the green light for production to begin. The super sports car is a master of aerodynamics. The air curtains at the front specifically guide the impacting air pressure through and past the vehicle. This presses the Chiron onto the asphalt and cools the brakes. The 1.5 meter wide rear spoiler adapts fully automatically to the respective driving situation. 0.8 seconds after applying the brakes, the adaptive wing tilts to an angle of 49 degrees, thus acting as an extremely effective air brake to decelerate the Bugatti. The hydraulic spoiler is the last of a total of 55 panel parts that the mechanics fit onto the hypercar. In 2017, the air brake played an important role in another world record. Formula One winner Pablo Montoya accelerated the Chiron to 400 kilometers per hour from a standing start. After 700 meters, he was already doing over 300 kilometers per hour. In the 33rd second, the Colombian racing driver reached the 400 kilometer per hour mark. He brought the 2-ton vehicle to a standstill again after 491 meters in just 9.3 seconds. By fully applying the brakes, Montoya took exactly 41.96 seconds and covered a distance of 3.1 kilometers to accelerate the Chiron up to its top speed and brake it. That was a new world record. The Chiron covers over 120 meters per second. That's nearly the wingspan of two 747s every second. Years of engineering succeed when they exceed 400 kilometers per hour. Now, the engineers can give the go-ahead for production to begin. After years of late nights and hard days, the team has achieved the first step in their quest. They can finally deliver the very first all-new Bugatti in over a decade. A force of 850 kilograms presses on the rear wing during maximum braking from top speed. This brings the hypercar's rear axle to its knees. During this sharp braking maneuver, forces of around 2G act on the vehicle and the driver. so that it's not scratched during its first test drive. The employees covering each millimeter of the hypercar with protective film. Covering the paneling takes around 4 hours. This hypercar has been fully covered. Later on, it'll demonstrate what it's capable of. Each Chiron has to complete a test drive of around 350 kilometers before being delivered. The quality tester now climbs into the driver's seat for around 5 hours. The cockpit is also fitted with protective covers. The tester also wears gloves so that no marks are left on the steering wheel. He tests different factors such as performance, the individual drive programs, and the background noise in the interior of the Chiron. If a leather seat so much as squeaks when cornering, the test driver notes this defect in his log. The tester then turns onto an airfield. Here, he immediately takes the Chiron up to its limits. He communicates with the tower crew via radio because air traffic is still operating, and that could cause a problem. The stormy weather also makes things difficult. The test driver quickly drives up to the 1.6 kilometer takeoff runway, then is given the green light from the tower. The expert hits the accelerator. He accelerates the hypercar up to 300 kilometers per hour in around 13 seconds. However, the primary objective is not to test the top speed, but to get the Chiron to develop its full output of 1,500 horsepower. Due to safety reasons, the hypercar is governed to 380 kilometers per hour. This special key can be used to accelerate it to a further 40 kilometers an hour. As soon as the high-speed key is engaged on the left of the driver's seat, the vehicle checks all of its systems fully automatically, because at over 400 kilometers per hour, any defect can immediately prove to be fatal. The Bugatti Chiron, a handcrafted masterpiece, an engineering marvel, and perhaps the best hypercar ever made. Hopefully not the last. After the stress tests, Chiron is taken to the company's own washing facility. The hypercar can only be delivered to its owner when it's absolutely clean. Bugatti, the French sports car factory, is absolutely incredible. At 12 high-end production stations in Molsheim, 20 elite mechanics produced the fastest, most exquisite, and most extreme hypercars in the world. With multiple world records, the French extremists have proved if it's comparable, it's no longer Bugatti.